Hi, today we're going to be doing a sealant installation video, and I want to offer a couple of comments before we get going. First comment is, yes, I represent a manufacturer of joint sealants. I felt that it was important to be able to name the product so if people have questions, they can direct it to the product that I have named, rather than hiding the names of the sealants and then they're saying, well, that tube in the blind cover on it, what was that? So, I do represent BASF, Master Builder Solutions, and I've been in this business for 30 years now, so I have a pretty good understanding of joint sealants. The only other comment I'll say is what precipitated this is the fact that I saw some videos online and I wasn't impressed with the content, and I saw how many people had viewed them, and then I saw comments afterwards and realized that people really don't know that much about joint sealants. So that's our focus. So this is educational, not trying to promote a product, just trying to give people a better understanding of why and how these sealants work, and that they're more than just goop in a tube. All right, now we're going to talk about the basics of joint sealants. First thing we're going to talk about is the joint configuration. I have a little mock-up here. It's a little larger than maybe a typical joint, but it does communicate some important information. The width should be twice the depth. Okay, so that's 2 to 1, 2 to 1, and I'll just put W to D ratio. So that's width to depth ratio. Okay, but that's an ideal. That's what you're targeting for. But there are 3 parameters. 1, the minimum width, min width of the joint sealant should be 1/4 inch. Minimum depth, top dead center. So top dead center is right here in the top center portion of the backer rod in the center. The minimum depth should also be 1/4 inch. And then finally, the maximum depth is 1/2 inch. So in this example, again, that's why I like to use it, that's about 1/2 inch or a little thicker, and that's the max that you would want for that. So that's the basics on joint configuration. What's important here is these items 1 through 3 override that 2 to 1 width to depth ratio. So for example, if I have a joint that's 1 inch wide, it could be up to 1/2 inch deep and still be compliant because it's at the 1/2 inch and it meets that 2 to 1 width to depth ratio. If I make that joint wider, it doesn't get deeper. So at 1.5 inches, it's still maximum 1/2 inch. Conversely, at 1/2 inch, my depth is 1/4 inch, 1/2 inch width, 1/4 inch deep. If I go to 3/8, I don't go to 3/16 depth. I stop at the minimum depth, which is 1/4 inch, in which case if I have a 3/8 joint, 3/8 wide, I'm still 1/4 inch deep. Okay? Next thing, so that covers joint configuration and min and max. Next thing, let's talk about bond breaker functions. Bond breaker can be in the form of backer rod, or it can be a polyethylene tape that releases the sealant on the bottom side. Let's talk about the functions though of bond breaker, and then we can get into a little more detail. 3 main functions. 1, to prevent third side adhesion. So in this case, we have a bond breaker, piece of backer rod. That backer rod pulls away on the bottom, which allows that sealant to move back and forth. That's very important. Okay. 2, that backer rod should be tight. So this is not tight in here. We want that backer rod tight so that when you're tooling the joint sealant, you can press against it and the backer rod will resist the pressure of the tooling and then drive the sealant to the sides. Okay, that's function 2. Function 3, besides giving something to tool against, it also is used for setting the depth of the sealant, which we'll demonstrate later. Okay, so we've covered backer rod function or bond breaker functions. So what happens when you get to a shallow joint and there's not enough room for the backer rod? And we'll show that over here again in a moment. Then you use a bond breaker tape and you lay that down on the bottom, caulk over the top. The sealant cures and releases from the tape, and so you don't have third side adhesion. So you're always trying to avoid third side adhesion, because if that sealant has to move, you don't want it tearing on the bottom because that tear will migrate up through to the top. Okay? Very quickly, let's talk about primer. We're going to demonstrate primer in a moment. And primer comes in a can like this. You don't have to use primer all the time, but certain sealants will require primer on certain substrates. So you need to be aware that primer is sometimes required. When we use primer, we pop the lid off, we pour it into a clean container. This is just a sour cream container. It doesn't have to be anything fancy. We pour it in a small amount and then use a brush and brush apply it in place. The reason why we do that, there's several reasons. We want that primer to retain the solvent that's left in the can. If you leave the lid off and dip and keep dipping, besides contaminating the can, you're also allowing all that solvent to fly up in the air. When that solvent releases, it loses content out of the can and the primer gets thicker. And so because it's thicker, it goes on too thick, it doesn't cure as fast, or maybe doesn't cure at all. So it's very important to transfer the amount of primer that you need into another container, close this lid immediately, and then come back later and get more if you need more. Okay, one last thing I was going to talk about that I didn't talk about before. There's different types of backer rod. There is what we call bicellular, trade name soft rod. There is closed cell right here. Look at how close those are in appearance. They look very, very similar, but if I squeeze this one, it's really soft. If I squeeze this one, it's got some resistance to it. And then there's open cell, which has a problem in that it absorbs water. Here's a container where I have put water in and put the back rod in, the open cell, and I can just show you as I squeeze it, that water comes out. So if somebody says, oh, open cell doesn't draw water, they're mistaken. It absolutely does. So BASF does not recommend open cell backer rod. Maybe in a dry climate it would be fine, but you've got to be aware that it'll wick water. We allow these two to be used, and I'll show you the differences between the two of them because there are some important differences. Okay, before we get really going on the application, I want to just talk about two different things related to the types of joints that can be installed on a building, especially on a residential application where you're doing siding, trim, and windows, or any combination of those. Okay, so the first joint is a butt joint. A butt joint is where you have a substrate on one side, a substrate on the other, the sealant in the middle, with the idea that these are expanding and contracting, which puts the sealant in tension and causes it to flex. Okay, a fillet bead, which some people call a cove joint, and I'm going to come up here close again. Look at the cross section on that. Now if somebody saw this fillet bead, they'd say, oh, that's a nice fillet bead. But look at the cross section. If you remember what we just talked about in the basics, minimum dimensions are 1/4 inch wide, 1/4 inch deep, and that's about half of that. That's like taking a 1/4 by 1/4 and slicing it diagonally. There's not enough mass there to perform the function of being in the position to expand and contract. The other thing that's a problem with the fillet bead is we talked about bond breakers needing to have no third side adhesion. We got adhesion on the back side, so you can't really move that joint very far because it's adhered on the bottom. Okay, so that's a problem with that type of joint. But as we see here, you've got applications where, and I'm going to step over to this side, we've got applications here where it's very difficult to do anything but a fillet bead. So we caulk these two beads right here, and then I left this one open so you could kind of see the width of the gap. Okay, for fiber cement siding, now they're saying in the field where boards come together that they abut one another. But at the trim or window interface, there's supposed to be a gap there of at least 1/8 of an inch. We're approaching 1/4 of an inch, which again is our minimum. But you will note that we have a bond breaker tape in here of 1/4 of an inch, so that if the sealant goes deep, it's going to contact that bond breaker. When it cures, it will release, and we won't have at least third side adhesion, even though we'll have a rather tiny joint. Now we're going to bring this board down because I have a couple more things to show you, and then we'll move on to the main demo, which will be showing how to caulk a butt joint or a dynamic joint. Okay, so we're talking about fillet beads, and we've lowered the mock-up down so you can see this a little better. So I'm going to have my camera guy come in, and he can take a picture from the top side. If you notice, there's the bead of sealant, and because we had that gap between the siding and the trim piece, it allowed sealant to get down into the joint, but because we have a bond breaker, there's no contact on the bottom. So basically we're just relying upon that approximate 1/4 by 1/4 inch joint to be able to expand and contract as the siding expands and contracts with differential changes in temperature. So when it warms up, that joint's going to get smaller because the siding expands, and when it cools down, that gap's going to open up a little bit because the siding has contracted. So that's the idea of a dynamic joint, is to be able to accommodate that thermal movement. So this little gap here is akin to our space here. There's not enough room to accommodate the movement in this application. All right, so earlier I made a comment about primer, and I said some sealants require primer, and I want to make sure people understand what I mean in terms of applying the primer, because that's part of the application should you need it. Okay, so in this case, we've poured a small amount of primer into this container. This is more than what I'm going to need for this. Pretend this is the siding, come on up to the trim, and the window is here. The window frame is here. So we want to prime this side of the trim board. And all we're really looking to do, keep in mind I cleaned this before. It doesn't look perfect because it's got some dings, but I did wipe this down so that it's clean. And on a primer, on a piece of wood like this where it's pre-primed, you want to you don't want to damage it, so you don't want to get really crazy with prep. When you see our horizontal joint in the next video, you'll see that you have to get a little more aggressive on a concrete substrate. This will dry in like 10-15 minutes in this kind of temperature, and then you'll be able to caulk over it. Couple caveats: you cannot go beyond the same day that you primed. In other words, you must caulk the same day that you primed. Okay, if you wait to the next day, you have to re-prime. So don't get so far out ahead of yourself that you end up with surfaces that are primed but are not yet caulked. The other thing to keep in mind, you want to install primer and allow it to dry before you install bond breaker, whether it's backer rod or the bond breaker tape. There's a reason for that. In the case of, I'll show you on the other joint, we're not going to prime on that, but if you put the bond breaker in first and you brush that primer, it gets in the nooks and crannies, and then it becomes a solventated material that has not dried. You can't tell that it's there. Then you caulk over it, and the solvent from the primer arrests the cure of the sealant, and it doesn't cure. Okay, so we're done with this application. We're going to go to the butt joint application and show you some more stuff and actually caulk some sealant. All right, so now we've got our window joint application up here. Note that we have trim halfway around the window frame. That's deliberate because we're going to come back later and use this mock-up for something else, so I did not put a sheathing, whether a building wrap or other type of weather-resistant barrier on here. We're just focused on the caulk joint. So we've already got a piece of back rod in up here. We're using a soft rod backer rod. There's a reason for why you would use the soft rod backer rod. One of the reasons is that it does not outgas. So if I damage it in any way, it will not outgas, because if it outgasses, it'll put bubbles in your sealant. So there's an example of installing the soft rod backer rod using a handmade tool. All I've done is staggered this out 1/4 inch, which is the depth I want, because remember, 2-to-1 width to depth ratio ideal. This is a 1/2 inch wide joint, so we want 1/4 inch depth, top dead center, meaning in the center of the joint. So that's why we have 1/4 inch. So this guide goes down the center, recesses the backer rod 1/4 inch, so when we shoot the sealant, you'll have a 2-to-1 width to depth ratio. 1/2 inch wide, 1/4 inch deep. Now, one thing I do want to show, I'm going to step back here because I forgot it. This is closed cell backer rod. I'm going to pull this rod out real quick. I'll replace it later when we actually do the caulking. This is closed cell, about the same size, and yet because it's firmer, it's got a gas core to it, gas-filled core. So it's tighter. And it goes in okay, and it keeps its shape pretty well. But when you try to set it with this backer rod tool, watch what happened. See how it damaged the face of the backer rod? When you caulk over that, that's going to cause outgassing because there's gas in the core of the backer rod, and it'll come up through the sealant and you'll have jelly bean size or bigger, especially down here, bubbles. So that's the advantage of using a soft rod versus a closed cell backer rod, is that if you nick the backer rod, there's no core gas filling in the core, so it's not going to outgas. So we're going to stop here and we're going to set up for caulking, and that will be towards the end of this video. Okay, the sealant we're using is called NP1. I don't caulk that much, but I'm going to see how I can do here, and we'll take it from there. The other thing that's an issue with this joint is the vinyl window extends up above the trim. Okay, now we're going to tool the joint, or attempt to. So I see I didn't get enough at the start, so you just come in, dab a little there, run a little bit down here. So it was pointed out by my cameraman that as I was tooling the joint, I was pretty quiet, and it's like, yeah, because I'm trying to focus on not screwing it up. I did get a little overage along the edge here. Yes, you can mask and tape. As I said, I don't normally caulk joints, especially with an uneven surface like that, so it's a little tricky to get that even and not get on the trim. Could have run a piece of masking tape, then pop that off, and it would have been clean. But I do want to point out something. Did you notice how I went up with the knife? People think, oh, you tool it down. When you tool it down, the material goes out to the sides. When you go up and push the sealant, you're actually cutting the top of the sealant. You notice I stopped once or twice midstream to clean that off the blade and then keep going. And then after you do that, you come back and pull down. I can see here, okay, I got one little pocket. I can come down here and tool a little harder. Kind of messed that up a bit. And bingo, that little bubble's fixed. Again, I wouldn't be happy with this on the edge, but I'm just being candid with you. I could have fixed that by just putting masking tape on that side, and likewise I had a couple of high spots on the other side, but that's tough because you've got an uneven surface. If you had an even application where these were balanced and you had the room, you'd get a wheel, which if you're doing a horizontal joint and a lot of linear feet, you screw in a pole here and you can install your back rod very, very quickly at the right depth. You just get this adjustment here on the back. If you have a deeper joint, you really don't want to go deeper than 1/2 inch, but you can set that at 1/2 inch, tighten it down, and then run your back rod in while a guy's ahead of you. So there's a lot of cool ways to address that. One last thing I want to talk about is after the sealant dries, how do you know that you've got proper adhesion? How do you know that? Because it looks pretty, it's good? No, there's ways to test it, and I'll just show real quickly. We do mock-ups with various types of sealants, but I'm just going to demonstrate how we do this. We conduct what's known as a pull test. So we will cut a tab of sealant. So here's a butt joint. This happens to be a textured version of that sealant. We'll cut it so that we're holding the tab at 1 inch, and then we pull up. And we keep pulling and pulling until it snaps. If the adhesion's good, you'll get cohesive failure of the sealant. If the adhesion's poor, it'll pull away from the sides of the joint. If you have dissimilar substrates, then I'm not going to do the actual pull, but you would cut a relief on one side, hold at the 1 inch mark, pull this way to test on this side, and then after you determine that, you would flip it so you would cut a relief on this side, cut a relief on this side, and then pull this way. And so you're actually evaluating two different substrates. So that's how a pull test is done if somebody asks you about it. But that's also how you verify whether you got proper prep, whether the conditions were right, whether the sealant was appropriate for that substrate, or whether maybe it needed primer. So if you have a lot of windows to do, I would do primed and unprimed, a couple feet of each, allow them to cure for a couple of weeks, then come back and do the pull test to verify that you have adhesion. If it passes unprimed, then you don't need primer. But if the unprimed pulls away and the primer adheres properly, then it's an application where you do need primer, and then you have to apply the primer, allow it to dry, and then come back, install your back rod, and then install your sealant. I hope you guys have learned about joint sealants from this presentation. Feel free, if you have questions, leave them in the comments section, and I'll try to answer as many, if not all of them, if I can. Thank you for your attention, and I hope that this proves useful for future endeavors that involve joint sealants and caulking joints properly. Thank you.